So hello and welcome to module 12th of the BCBR series. So we are moving briskly now, calculating sample size and error objectives to understand the relationship between the sample size and power and determine the sample size necessary to achieve a given level of power, estimating a simple proportion or other measures of effect. Steps in estimating sample size are identify the major study variable, determine the type of estimate, mean, ratio, etc. Indicate the expected frequency of factor of interest. So we have to indicate and then decide on desired precision of the estimate. Decide on acceptable risk that estimate will fall outside its real population value. Adjust for population size, adjust for estimated design effect, adjust for expected response rate. So we have to do all of that. Now alpha in the confidence level. Alpha significance level of a test, the probability of rejecting the null hypothesis when it is true. The probability of making a type 1 error. Okay. Confidence level, the probability that an estimate of population is within certain specified limits to true value. So alpha is, for example, we propose a null hypothesis that with this thing, for example, a factor A will not affect factor B. So this is a null hypothesis. So the probability that the null hypothesis is false when actually it is true is alpha. So it is type 1 error. Now beta and power, the probability of failing to reject the null hypothesis when it is actually false. Okay, so when a null hypothesis is false, that there is a effect between the factor and the outcome, but we are proposing a null hypothesis and actually the null hypothesis is false, then what are the odds that we reject the null hypothesis is beta, that is type 2 error. The probability of rejecting a null hypothesis when it is false is denoted by power, that is 1 minus beta, and 1 minus alpha is probability that an estimate of population is within certain limits of true value. Precision, measurement of how close an estimate is to be true value to the true value of a population parameter. It may be expressed in absolute terms or relative estimate. Sample size required for estimating population mean. When we want an interval that extends d units on either side of the estimator reliability coefficient to standard error, sampling is from population sufficiently large size. The equation is d is z by n. When solved, it gives n is equal to z square minus theta square divided by d square. Example, what sample size do I need if a health department nutritionist wishing to conduct a survey among the population teenage girls to determine average daily protein intake? What information needed to estimate sample size? The nutritionist must provide 3 items for the information: the desired confidence desired and the magnitude of population variance also. Notation is like an interval about 10 units wide that is estimate should be within 5 units of the true value. Confidence coefficient of 0.95 is decided on the past experience. The nutritionist feels that population standard deviation is probably about 20 grams. So summarizing information, z is equals to 1.96, theta is equals to 20 and d is equals to 5. So d is the 5 deviation, 10 units wide, so 20 will be the confidence and reliability coefficient. Okay, and 1.96 square is z square, that is square is 61.47. A note on population standard deviation formulas: sample requiring knowledge of I don't know what to say this sign, this is a circle and a single dash. However, in general population variance is known and has to be estimated. A pilot or preliminary samples observations used in pilot can be counted as a part of final sample. Estimates may be available from previous studies. It is thought that population approximately normal distributed. We may use the fact that R is approximately equal to 6 standard deviations. Okay. Sample size required for estimating proportions. The formula requires knowledge of P, proportion in which population possess the characteristic of interest. How this is what we are trying to estimate and is unknown. Pilot or preliminary sample observation used in pilot study can be counted as part of final sample. Estimates may be available from previous studies and the upper bound of P can be used in formula. It is impossible to come with better estimate. P is equals to 0.5 in the formula yield the maximum value of n. Sample size required in estimating proportions. The method essentially is of same population mean. Assuming random sampling approximately normal in the distribution of P brings us to formula of n. If the sampling is replacement Now population sufficient large to warrant the ignoring finite population correction z square pq by d square, where q is equals to 1 minus p. Okay. Example 2, what sample size do I need if I want to estimate true immunization coverage of community? Tell us immunization coverage is somewhere around 80%. Precision will take the result to even 4% of the true value. So confidence level convention is 95%. 1 minus alpha is 0.05. That is 0.05. Okay. And Z 1 minus alpha by 2 is 1.96. Value of standard normal distribution corresponding significance level of 0.05 is 1.96. Okay. This is by research studies. Okay. So D is absolute precision, that is 0.04. Okay, within 4% of the value. P is expected proportion population is 0.8. Z 1.96 value. Okay, so sample size is Z square minus P into 1 minus P upon D square. So Z square is 1.96 square, P is 0.8, and 1 minus C is 0.2 divided by 0.04 square, D square is 384. Okay, now the design effect. The bias and variance introduced in sampling design was selective subjects whose results are not independent from each other. Relative change in the variances due to the clusters. A design effect has to be calculated after study completion but should be accounted for the design stage. The design effect when taking a simple random sample design effect varies. Using cluster sampling usually estimated the design effect in 2 immunization cluster surveys. What do you need to calculate sample size? Desired values of probability alpha and beta. Expose case control studies, disease to Zyga, and often based upon previous studies or reports. Magnitude of expected effect often based on previous studies reports. Minimum effect external investigators. Formula is when our study design research question and type of data. What sample size do I need if? What sample size do I need if? The third example is there. So third example is cohort study of an OCP in use of MI among women of childbearing age. Proportion of non-OC users is 0.15. Proportion of OC users 0.25. Conventional alpha is 0.05, that is 1.96. Conventional beta is 0.2. 80% validity only one truly exists. Assume equal sample sizes. So Q is 0.85, Q to that is equals to value of standard distribution 0.84. Okay. So the complex formula. What size sample do I need if case control OCP in relation to risk of MI 10% versus OCP? Odds ratio is 0 and conventional alpha is 0.05, beta is 0.20, proportion of OC users is P0. So Q0 is 1 minus P0, that is 0.9, and Q2 is 1 minus 0.1 and 0.82. So we are going to multiply both of these and add Z 1 minus alpha 1 minus beta. So 1.96 plus 0.84 square. That is approximately 3 square, that is 9. Yeah, 1.96 plus Q square is 4 to use of that. Sample size case control study of OC use in MI 1.2 is 3834, 1.3 1.7. Okay, odds ratio 682, 1.2 91, odds ratio is okay. The 10% rule is note that sample size estimate should be interpreted as providing a minimum estimate sample size necessary for study. Formula takes into account not overall crude associated with exposure disease confounders. 10% increase sample size, increase sample size 10% each for confound variable added. Free soft ways to sample size open API. For sample size correlation vulnerability. Okay. So statistical. Okay. Now the MCQ is the next module.